All right. So they're saying we are taking a sheet of paper that has a perimeter of 36 centimeters and dimensions x by y. Okay, so we don't know what the sheet of paper looks like. But we know one dimension is x and one is y. And we know the perimeter is 36. This, again, that doesn't make sense that we're going to... That's a weird constraint for us to have. The perimeter of a paper has to be 36. But whatever. It's 36 inches or centimeters for us. So all that tells us is that the perimeter, which is 2x plus 2y, has to be 36. That's not what we're trying to optimize. That's just a given fact. The paper has to have that property. Okay? We want to know if it's going to be rolled into a cylinder, what values of x and y give the largest volume. So we're going to take this thing and we're going to wrap it into a cylinder, like an open cylinder, I guess. Okay? And we want to maximize the volume. So the problem with this is the volume of a cylinder is not 2, is pi r squared times height. Now, in terms of our variables that we started with, what's the height of this thing? Huh? Oh, you want it to be y? Well then, let me change these then. Okay, if that was the consensus, then fine. All right, yeah, the height's y. That's an x. The height's y. Okay. But the radius doesn't come out as nice. So now we need some kind of other equation here to link x and r, because the equation we have up here is x and y, and then down here we're going to have r and y. So basically our volume equation is going to turn into pi r squared y, right? So using this equation we have up here in this box, we're going to be able to get rid of y for x or x for y, but we got to get rid of r. So what equation is going to link? So we need this other equation. What is it that's going to link x and r together? Circumference. The circumference is x, right? But it's also 2 pi r. Cool. So now we have two restriction equations here, and we need to go down to our optimization equation and get rid of either r or y, whichever one we want to get rid of. Since we have r in terms of x and we can get y in terms of x, I think we switch everything to x's. Cool. So r, if you solve this equation up here, r is going to be x divided by 2 pi. Okay? And y, if we solve this equation up here, y is going to be 18 minus x. Okay? And again, so that's what we talked about. The tricky part of this usually isn't the calculus. The derivatives are usually relatively easy. It's getting to the equation and then simplifying it and solving for the critical numbers. So this volume equation is going to become pi times r squared, well that's x over 2 pi squared, times y, which was 18 minus x. And before we derive it, we're going to simplify it down. So this will simplify to 1 over 2 pi x squared times 18 minus x. Okay, because you're going to square, oh, that should be a 4 pi, right? Sorry. One of our pi's are, we're going to have pi squared in the denominator, but it's going to cancel with the other pi. And if you square x and 2, you get 1 over 4, and there's an x squared there. And then we need to distribute this. So the volume's going to be 18 times 1 over 4 pi is the same thing as 9 over 2 pi x squared minus 1 over 4 pi x cubed. So we got these pi's, you might not like them, but the derivative is going to be easy. So dv dx is going to be 9 over pi x minus 3 over 4 pi x squared. Now I want to know where that's 0, so what can I do here? Even though we have these ugly fractions, what can I do to solve this? This is not a difficult equation to solve. What can I factor out of there, Anthony? Talk to me. We can factor out a 3 over pi. We can also factor out And that. Yeah. That's going to leave us with a 3 here, a 1/4 x here. Right? If you multiply back in, you get 3 over 4 pi, yeah, x squared, and 9 over pi x, yeah, okay. So, we get 2 answers. X is 0, and from the other one we get x is 12. If you make your number line, test this out. Remember, the perimeter of this thing has to be 36, right? So the largest x can really be is 18. Cool. But if you plug in a number less than 12, like 1, you get a positive times a positive, which is positive. If you plug in a number bigger than 12, like 17, you get a positive times a negative, which is negative. Which means the graph of volume is going up and then down, and it's maximized when x is 12. And this question says, what values of x and y give the largest volume? So we want x to be 12, and we want y to be 6. Because of that equation right there on the screen. So x is 12, y is 6, and they're both in centimeters. Remember your units. Okay.